Remember that what we solved last time is only for compartment X. And now, since we are asked to solve for compartment Y, so how we gonna do it? How we gonna solve it in terms of Y? So remember we are given the first equation, x plus y plus is equal to x sub o plus y sub o. And now deriving all the compartments with respect to time, that will give us dx over dy dt plus dy over dt is equal to, since these are all constant, this will be equal to 0. Therefore, our dy over dt is equal to negative dx over dt, or dx over dt is equal to negative dy over dt. So now we can substitute this to this part, but since we have still our variable 2x here, so we can also get it from the first equation, and that will make, by multiplying this one by 2, I think you can have it the other way, but make sure that we have this factor, or this variable negative 2x. So we have 2x plus 2y equals 2xo plus 2y sub o, right? And making it 2y sub o minus, 2y minus 2x sub o minus 2y sub o is equal to negative 2x. And we have here a negative 2x and our negative 2x here. And arranging it further, this would give us this equation, negative dy over dx is equal to k a over v. Wait, let's make it clear. K over v times x sub o plus y sub o, and our negative 2x will be plus, no need for that, 2y minus 2x sub o minus 2y sub o. And arranging it further, we're gonna get dy, negative dy over dt. How am I using x? So it's always dt because it's the great thing with respect to time. And this is k a over v times negative 2y minus xo minus yo. And now we have the solutions in terms of y, so we can now solve it, and we can now get the solution in compartment y. So joining like terms, just like what we did last time. So we have here negative dy, so you can see it, negative dy over 2y minus x sub o minus y sub o is equal to k a over v dt. Integrating both sides again, we'll get, we will let u equals to, okay, since we've used u last time, now I'm gonna use v. That v is equal to 2y minus xo minus yo, and our dv equals 2 dy, 1/2 dv equals dy. And now negative 1/2 dv equals negative 1/2 dy, right? So we have negative 1/2 integral of dv over u is equal to k a t over v. And integrating it, we have ln of u, or v, yeah, remember we are using v to the negative 1/2 is equal to k a t over v plus ln c. Sorry, I forgot to put the ln c here. Now to simplify it, you have ln v to the negative 1/2 over c is equal to this one, this term, K80 over V, and raising it both sides to E, you'll get 1 V negative 1/2 over C, so to E to negative K80 over V, or we can put C here. So sorry for doing it fastly and making the space count because we're out of paper. So multiplying it by negative 2, we'll have V is equal to C E to the negative 2 K80 over V. So let me first remind you that the V here is a volume, and the letter V here we use is another variable, so please don't get confused. And now returning what we have substituted, or what we let for V, we have 2y minus xo minus yo equals C e to the negative 2k 80 over V, right? So 2y is equal to xo plus yo plus C e to the negative 2k 80 over V, or y is equal to this term all over 2. And now we know that at t equals 0, then initially our y is equal to y sub o, and that will make y of 0 is equal to x sub o plus y sub o plus c. This one will become number 1, so equal to 2y sub o, right? So we're gonna continue here. You see a space here, so that will give us C is equal to y sub o minus x sub o. Okay. And now we're gonna substitute it here, and that will give us an equation. Okay, I'm gonna use more bond papers, I think. Okay, this one. This will give us an paniki. This will give us, okay, from here, and we're letting C be this one, and that will give us the final answer of y of t is equal to x sub o plus y sub o plus, or C, y sub o minus x sub o e to the negative 2k 80 over v all over 2. And finally, we got now the concentration of the solution in both compartment X and Y. And thank you for watching the 5 consecutive solutions manual from Wylie 5th edition book. Thank you for watching, and God bless. Dasig AMB.